Hi guys, this is Mr. Richard, the Innovative Minds Tutor. So in this video, we are going to work with center theorem. Yes, remember that states a line from a center is perpendicular to a chord. But today we are going to work with typical exam question. Consider this question. In the diagram below, in the diagram, O is the center of a circle, ABD. We can see ABD. F is a point on the chord, AB. We can see there's F there. Such that DOF, where is DOF? DOF is perpendicular to AB. You can see it forms 90 degrees. So AB is equals to FD. So let's write that first. AB is equals to FD. Is equals to what? 8 centimeter. So meaning that here, meaning that AB, AB it's 8 centimeter. So since a line drawn from a center of a circle is perpendicular to a chord, so that makes this part equal to each other. They're equal. So since they bisect the chord, they're equal. So it makes this to be 4 centimeter as well as this to be 4 centimeter. So that's the first thing that we can write there. AF is equals to FB, which is equals to 4 centimeter. Reason, line from a center perpendicular to chord. Line from the center perpendicular to chord. Right, okay. Line from the center perpendicular to chord. So we can see that AF and FB are equal to 4 centimeter. Right. Without panicking. The question says determine the length of the radius of the circle. So the length, it could be, they're talking about OB and OD. So those are the radiuses, right? So we need to find the length. How do we find the length? We can see that OB is missing. We can apply a theorem of Pythagoras, right? So let's say OB, since it's the hypotenuse, OB squared is equals to, our opposite side will be OF. Our adjacent side will be FB squared. FB squared. So we can use Pythagoras theorem. Pythagoras, right? Can use Pythagoras, theorem of Pythagoras. So first thing first, guys, we can see that OD and OB are equal. Why I'm saying so? Forgive me when it comes to sketching my circle accurately. Use a rough hand, but we can see that OD is equals to OB. Reason, they are radi. Yes, they're equal radi. So in other words, what we could do there, we can just say OD is equals to OB. So we can find OD. Why? How can we find OD? Remember that AB is equals to FD, which is equals to 8 centimeter. So we can see that FD, it's remember we were told that it's 8 centimeter. So we can find OD. How do we find OD? We are going to subtract FD with OF. So we are going to have 8 minus X in this case. So how did I get I said FD? Let me show you how did I came up with 8 minus X here. FD is equals to OD. So these are the parts that form OD, that forms FD. So it's OD and FO. And FO, so we are given that FD is 8 and OD, it's unknown. But FO is known as X, or OF is known as X. Then you can transpose X to the other side, it becomes negative. So in this case, we are having OD as 8 minus X. So OD and OB are equal to 8 minus X. Reason, they have the same radii, they are equal. already. Right. Oh, right. So we saw that even here it's 8 minus x. Are we done? We are not done. Let's go back to our theorem of Pythagoras then. Let's go back and apply. Remember that we have OB, we now know that it's 8 minus x squared. Therefore, our OF is given as x squared. Then what about our FB? FB it's 4, so it's going to be 4 squared there. So what are we having? X squared. 4 squared is 16. So let's apply. What is 8 squared, guys? 8 squared, it's 64. So let's simplify this bracket. 2 times negative x is negative 2x times 6 times 8, that will be 16x. Then let's square negative x squared, that will be positive x squared. Then let's collect the like terms, guys. If we can take 64, take 16 to the other side, it becomes minus 16 minus 16x. Take x squared to the other side, it becomes x squared. Then since it's a quadratic equation, equate it to 0. So what happens? Let's see. 64 minus 16. What is that? 64 minus 16, that is 48. Minus 16x. So we can see that this and this cancel because they give us 0. So we are left with equated to 0 there. So we need to solve for x. We are not done. Take 16 to the other side, it becomes positive. So we can divide both sides by 16. 16 divided by 16, we get x here, and 48 divided by 16. What is that? I think that's 3. X is equals to 3. It goes 3 times. So in other words, x is equals to 3. So that makes the length of the radius to be, let's see, if we can say 8 minus 3, what are we getting here? We are getting 5. Similarly, even you can say 8 minus 3, we are getting what? 5. So what is the length of the radius? Let me write the final answer. Length of radius is equals to 8 minus 3. So that will be 5 units. So that's the length. Oh, that won't be 5 units because we are given in centimeters. Sorry for that. That will be 5 centimeter. So if we were not given, so we'll write units, but we're given in centimeter. So this is how, guys, you can work out such typical exam question that requires you to apply center theorem that says line from a center perpendicular to a chord. Right. Well, we are left with cyclic quads on our series of video. We will dwell on cyclic quads on our future videos. So if you are new to this channel, guys, what are you waiting for? Let's subscribe and grow the community. We are already on 330 subscribers. Remember, our goal is to reach 1K. Yeah, we can do it, guys. We can do it. Share the video. Don't forget to like the video. Don't forget to like the video, because if you like the video, you'll be able to reach more audience. So don't forget to like the video. Remember, we love you.